Thank you. Yeah, so everyone, we're doing a problem here. This is 2.3, number 11. I just did number 10, and I have a written record. So maybe later on in a later question session, I can bring up my notes for number 10. This is number 11. All right. Okay, so we're doing long division here. We're dividing a third degree by the first degree. The divisor goes on the outside. The dividend goes on the inside. All right. Okay, now let's perform the long division. We're comparing the leading terms. We have the x here. We have the 15x cubed over here. All right. So we divide 15x cubed by x. We get 15x squared. And we should put that in the x column, the x squared column. We should line up our like terms. All right. So we have 15x squared up there. Okay. Yeah, these numbers are kind of bad looking, huh? And then what do? We multiply the 15x squared by the x. I'll just do this in black. All right, so 15x squared times x is 15x cubed. That was the whole point. And then 15x squared times negative 3 is a negative 45x squared. All right, but wait. We want to subtract this thing, right? So in order to ensure accuracy, I think a good idea is to actually write the opposite now. So I'm going to write down the opposite right now. Okay, when you subtract, you add the opposite. We're going to add negative 15x cubed plus 45x squared. When you subtract, you add the opposite. And then I'm going to cross out the middle guy. All right. Now, I know that students don't like to do this because they're thinking, oh my gosh, do I have to write 3 lines? Well, here's the thing. You want to be accurate, and this is the best way to do it. When you subtract, you're adding the opposite, okay? And then cross this piece out. And then it's just a matter of combining like terms. Remember, you're really good at adding. You're much better at adding than subtracting. When you're adding, you're basically just combining like terms. All right. So 15x squared and negative 15x cubed and negative 15x cubed, they add up to 0. That was the whole point, right? We wanted to cancel out these terms. Over here, negative 52x squared and a positive 45x squared, you end up with a, I'll put this in dark blue again, you end up with negative 7x squared. All right. Okay, we're not done yet. When I say combining like terms, don't forget to bring down these 2 terms over here. We also have the plus 19x and the plus 6. All right. This is kind of like our new dividend, right? This is degree 2. This is degree 1. We're not done with the process yet. Okay, because we need the new guy here to be either 0 or of degree less than this degree here. We're going to need a constant, basically. All right, we're not there yet. So what's negative 7x? Okay, so here's our new leading term. The negative 7x squared. Whoops, the negative 7x squared. What's negative 7x squared divided by x? Negative 7x squared divided by x is going to be negative 7x. Put this in the x term column over here. Now we multiply. Negative 7x times x, I'll put this in black, is negative 7x squared. Okay. Negative 7x times negative 3 is, watch your signs, it's positive 21x. And what do we want to do with this thing? From here, we, if you look back at the old arithmetic example, right, from the notes, 9 divided by 4, we want to subtract. When we subtract, what's an easier way of doing that? Adding the opposite. Positive 7x squared minus 21x. Put a big line there. And let's cancel out this guy in the middle. I don't need him anymore. All right. Now we combine like terms. We're adding, right? To subtract, we add the opposite. Here's the opposite. Negative 7x squared and 7x squared, bye-bye. 19x minus 21x, that's a negative 2x plus 6. All right. Oh, and here, I guess we get pretty lucky because negative 2x divided by x. Yeah, negative 2. Negative 2 times all this. Yeah, you're right. It's the twin. We get negative 2x. Negative 2 times negative 3 is positive 6. You know, I'm not going to pull this stunt anymore, right? This minus himself, it's 0. You buy that, right? It's 0. Which means, of course, that we're done with this phase of the process, all right? And then, well, really, the answer is right here, right? The remainder is 0. I don't have to write that funky fraction. This is the answer. You're right. I wouldn't put it past myself to miss my own question. All right. I've done it before. 11A. Well, 11A and 11B should give me the same. Good. 15x squared minus 7x minus 2. Good. I'm actually relieved I got my own answer. I wouldn't put it past myself to make a mechanical error. So yes, if you're ever asked on like a math test, right, like a polynomial long division problem, look back at my notes. Look back at, well, how did I do 9 divided by 4, right? Put the 4 on the outside, 9 on the inside. Okay, how many times does 4 go into 9? Twice, whoops, twice, that's the quotient. Multiply, subtract, remainder. So this is inspiration. Yeah. But no, I mean, you could ask any number of calculus students, hey, can you do this polynomial long division problem? I'm sure you'll have A students who have forgotten. So, but remember, here's the key lesson. If you forget a procedure, look at the basic examples and build off them. That's been a key theme. All right. Okay, B is synthetic division, right? Put the 3 in the dunk tank. That's faster. You can see why we like synthetic division, right? Because there are patterns here that synthetic division exploits. And you remember, synthetic division is fast, right? A calculator might help, but synthetic division is fast. In fact, part of the reason why I assigned this was my sales pitch for synthetic division. Because it's going to be clear to students, oh my gosh, synthetic division is so much faster than long division. All right. Okay. And of course, if you have questions, we can revisit. Are there any further questions? Okay. I can stick around till 10:30, but if you're tired, I don't blame you. Any further questions? Okay. Oh, yes, you're very welcome. Yes. Thank you for your perseverance. Commitment shows commitment. Anyone else? Any questions? Or if you want to tell me, wait up for 5 minutes and we'll come back. I'll wait a couple of minutes. So I'll come back at 9:51. And if there are any more questions in chat or anything, I'll come back at 9:51. All right.